Okay, so this is a week 10 of Psych 3280, Neural Basis of Consciousness. And today I'm going to talk about integrated information theory of consciousness. So to recap the contents of the week 9, I first demonstrated that attention can operate without conscious experience of an object. And as an example, I started off with a blindside situation where blindside subjects were cued by invisible stimulus, and then blind subjects' performance, namely reaction time, improved on the cued location, but slowed down on the uncued location. And still, blindside patient said that neither cued or target stimulus was invisible for him, and detection performance-wise or localization performance-wise, he was above chance, but not really different for with and without attention, the cueing stimulus. And then in the second example, I showed that the sort of similar homologous experiment in healthy individuals using continuous flash suppression to suppress the searched for target, yet their eye movements tend to move towards the location of the hidden invisible target that they are attending to and searching for. And then finally, I showed also the Bahadur-Barami's experiment where using fMRI, they again used the CFS, continuous flash suppression, to suppress the intact object. And then the location of the V1 that corresponds to the stimulated location increased its activity when subjects were not paying attention to the demanding task at the center, whereas when they were doing some simple non-demanding task at the center, the activity in the V1 spread to this invisible object much stronger. That's an evidence of the neural amplification with residual attention left from the central task. Okay, and then the second part of the video, I discussed evidence for consciousness without attention. And here I mainly talked about the details of the dual task paradigm, and especially my student, a previous student, Julian Matthews' paradigm, where we looked at whether we can perceive faces or red-green disks without top-down attentional amplification. And attention was there, controlled by the highly demanding central task always. And under the same attentional conditions, in the case of the face genders, people were able to see the gender of the face without training and with metacognitive accuracy. So that uncovers or that sort of resolve the previous problem of the dual task paradigm, which is associated with the lengthy training and the possibility of unconscious response in the dual task paradigm. On the other hand, the red disk circle, red-green disks were not possible to discriminate without attentional amplification. And that was true even we rescued the task with the partial report paradigm. So there was no confound or demand of the memory, but still they couldn't see it. And the final killer experiment that we reported was that attention, that object where faces were painted with the red and the green, and then subjects reported that under the no attentional amplification situation, they were able to see the face aspect, but not the color aspect of the disks. So that is also backed up by the psychophysics performance with the metacognition only for face, but not for the disks. And the important thing I emphasized was that the difficulty of the task for the face and disks were always equal when they are done as a single task performance. And these differences only emerged under the dual task paradigm. And then towards the end, I discussed that, so before that, the important thing was for you guys to understand the logic of the experiment, not too much for the conclusion of the experiments, and also how asking how conscious perception is manipulated and measured, as well as how attention is manipulated and measured in these paradigms. And then towards the end, I discuss about the sort of the attention equal activation amount equal the degree of consciousness, and also amount of attention type. Simple idea of sort of the scalar amplification of things always gets to consciousness or attention kind of idea, which is very naive, but still predominant across all the domains of research, from philosophy to neuroscience to psychology. But these are pure, basically, impossible to, reconcile with all this knowledge that I tried to deliver to you over the last 2 weeks. One is that attention operates not only for amplification, but also suppression of the unwanted stimulus. That's one thing. And also conscious or unconscious is not a matter of the degree of the activation. And that's one of the things that I'm going to talk today. So that's one thing. And then as an alternative to explain consciousness as well as attention is that it's not the amount of the activation itself, but the patterns of activation or complexity or informativeness or relationship between the of the activation between the neurons. That's the sort of the entire bigger picture of the lectures going from week 10 to 12. So then in week 10, this week, we will introduce the integrated information theory of consciousness. And this is basically focusing more on the relationship, complexity, and also information aspects of the process, but more important aspects I'm going to explain. And this week, I will discuss this without any mathematics. And next week, I'll introduce a little bit of mathematics, but don't worry, I'm not going to use lots of equations. Okay, so the learning objective of this week is to be able to answer the following questions. First of all, what is IIT? It's difficult question to really correctly and fully answer, but the overall general answer to this would be enough. Integrated information theory and how it goes from where and then and where. So basically, where does IIT start, which is phenomenology, and then to construct a theory. Okay. And then what are the 5 core properties of everyday phenomenology that IIT considers important? And that's also, explicitly stated in the slides, so it should be easy to find the answer. And what is a neural measure that was inspired by the IIT? And that's also the last part of the video, so it's also easy question to address. And as a reading material, I put one of my paper written for the philosophers, so written in a journal called the Philosophy Compass. And this one also doesn't use much of the equations or mathematics and intuitively explain IIT. So if you're interested in this topic, please take a look, but you don't have to read this paper to answer the quiz for this week. This YouTube link, it's an going into the details of the how IIT computes each of these quantity that I briefly covered in this lecture. And if you're interested in that, then reading the papers that I mentioned in this this tutorial or watching this 2-hour video may be a good starting point to get used to the IIT. All right, so the first part of the lecture addresses and also recaps the very first lecture that I gave for this course. Why do we need a theory of consciousness? So week 1 to 7, I tried to establish a basic building knowledge for the consciousness research, starting from neurons and also especially the visual cortex, early visual areas in anatomy and physiology. And then there, mainly I discuss about between a relationship between consciousness and the brain, but in a loose sense. Okay, and then week 8 and 9, we came closer to the latest research on consciousness, especially through the lens of the relationship between consciousness and attention. It's still like controversial kind of topic. And then, as you might have already felt, the knowledge from week 1 to 9 is already quite large. And how can we make sense of all of what you learned? And if you have been attending to all these, tutorials or, amount of the research that has gone on from 1990s, it's really huge. So one reason why we want to have a theory of consciousness is to understand all these findings in a coherent manner and to make a useful prediction. And then another thing is that we want to address the core question of consciousness by extending these approaches. But empirical question always generates further question, but it doesn't necessarily get to the core or original kind of question, such as why the vision feels very differently from audition, or why do we ever feel anything after we wake up, and so on. This is so fundamental, and sometimes this kind of fundamental question has to be addressed from more theoretical or basic point of view. And then important thing is that also to make a further progress, we need a theory to make not only explanation for the findings in the past, but also to make a prediction for the future. And that's another role the theory of consciousness has to play. So this is the slide that I gave you as a sort of brief history of consciousness research, starting from philosophical discussions and Descartes, and then some psychology fathers, Fechner and William James, and then 1990s and so on, neuroimaging studies has started to explode, and then David Chalmers pointed out how the problem of consciousness, and then now today I'm going to talk about this in Tononi's integrated information theory of consciousness. So around 1990s, not only the explosion of the neuroimaging studies, but also Christoph Koch and Francis Crick started to propose a research program to find the neural correlates of consciousness, the NCC. And here, what they propose essentially is that you have things outside the world, like seeing the dogs and people, and then when you see it, something happens in the eyes, and then that gets delivered to the visual cortex, and then to reach to somewhere in the brain, and then to activate the neurons, and that neurons activity is always corresponding to subjective conscious awareness of this, dog. And I showed this figure in the first lecture, and at that time I didn't mention this explicitly in the lecture, but here as you can see from this figure, Christoph Koch, my supervisor at that time, was probably thinking more or less like hippocampus or amygdala or somewhere where he was recording a single neuron from. If you remember, a couple of weeks ago, Jennifer Aniston neurons and also Sydney Opera House neurons were discovered around here from epilepsy patients, and also IT cortex that has an object selectivity that's located here. And these high-level visual areas attains, have an population of neurons whose firing tend to correspond to some kind of concept invariant to the detail of the figures. And that was sort of proposed sort of a subset of the neurons that are tightly and strongly correlated with any particular one percept. That picture was already kind of indicative that it's more or less a neural correlates of a consciousness, but also more to do with a high-level conceptual structure or something that is reportable to from the subject. But it's less to do with this qualitative aspect of seeing the dog, like fluffy furs or shape of the ears, or the color of the blackness of the nose of the dog. this type of stuff is likely to be located more to the with the posterior part of the brain around here. And also, what for some reason we still don't understand, but the pattern of the activity of the neurons across the brain is in some way coherently generates some quality of experience, like seeing dog in this way but not the other. So the NCC program itself is implicitly assuming that there was something to do with the population of the neuron activity. And then our path so far, especially from lecture 1 to 7, was to guide you, and also, this is actually the path that many of the researchers since 1990s or even before have been taking, like trying to address the empirical question: is V1 located within the NCC, or is attention and consciousness different, or is the frontal lobe related to consciousness? And then eventually mapping the NCC across the brain to arrive at the sort of the question, the answer of holy grail of neural basis of consciousness. That's the sort of the strategy. And this type of a strategy has been criticized by philosophers. Sometimes they call it this type of approach as a sort of easy program or extension of the previous studies. So their category is that categorization of this type of approach is that this type of the study is just trying to explain observable behaviors from the neural activities, and it doesn't get to the sort of the top of this mountain, which is the hard problem. And here the approach can be summarized as any kind of the research program trying to find the correlational evidence between the conscious perception and its report with neural activity. It doesn't matter whether you use perturbation like TMS to stimulate the brain to break the correlation into the causality, but it's as long as you have trying to establish conscious perception on one hand and the neural activity on the other hand, then that's a sort of correlational laws as best as you can. And that kind of approach is not going to get to the top. That's what they are saying. So it is the same kind of criticism or question that I repeatedly came back during the course of the lecture, where for example, when I talked about face areas or color areas V8 or visual motion area MT, somehow it seems like the activation, artificial activation, stimulation of the MT neurons seems to generate a seeing of the motion, or stimulation of the FFA generate a face perception and so on. So activity of the neurons in particular area in the brain seems to generate some qualia, particular aspect of the consciousness in us. However, why these type of the neurons activation result in this qualia? This part of the arrow is very difficult to understand. And if there isn't any kind of function or any kind of rule that says such and such neuron's activity and the connectivity has to result in this conscious experience, then we are in a much better situation, but we are far from that kind of laws. And in fact, I also mentioned that if you look at each of the neurons, say FFA or MT or V4 or VA, probably at the level of the individual neurons, there's nothing that we can find that is specifically related to each of the qualities, such as motion or face or color. There's no molecules or synapses or action potential that corresponds to the quality of the seeing of the face or motion or color. And what it is that generates this in particular qualia, that's a question, and it's a hard problem. So according to some philosophers, these kind of hard problem can be logically argued that it is in fact hard. And some of the arguments are listed here, such as zombie argument or inverted qualia argument or knowledge argument. And basically, what these are saying is that why or how certain neural activity must give rise to consciousness cannot be explained in this order, in this type of approach, because we can logically, or we can at least imagine a world that is consistent with the non-physical laws in the physics, such as electromagnetism or gravity, and also particle and so on, which has everything consistent with what we have, but some people who exist in this world who doesn't experience color, even though their B4 neurons or B8 neurons are wired in the same way as us, and then activity also give rise to something very similar to us. Every aspect of the brain and molecules and chemicals are all the same, but as long as we can imagine this entity, philosophical zombie, which doesn't have any qualia, or those people who have completely inverted qualia, like when I experience blueness on the screen, that particular person may be inside experiencing yellow. And then if all of the history and also all the language usage or meaning is completely inverted across red, blue and yellow between me and that person, then we may not be able to detect any kind of the difference behavior. That's a sort of inverted argument. Another argument is that we can imagine a neuroscientist who was born without seeing any color, and then raised without seeing any color, and then but still that particular person, Murray, famously learned all the neuroscientific knowledge up until the university or something like that, and then she absorbed all the knowledge about the color experience and the color psychophysics and the color neurophysiology, but she has never experienced the color by herself. And then when she was first exposed to the color outside the world, in this hypothetical situation is that Mary was raised in a black and white room for all the way up to here, and then if she can experience this color for the first time, does she gain anything new other than what she has already learned? And as long as there is something above and beyond, then what is it? That's a sort of the question they're addressing. In my mind, and also, those of you who have followed the lectures so far, all of these things are not really empirically, possible, most likely. For example, the knowledge argument is, I think it's completely flawed that, if the person who can experience the color for the first time they see in the world when they are exposed must have, most likely, the color experiencing circuit in the brain. So they should probably also experience the color through imagination or dreaming. But anyway, so I'll cut the details of the argument. But anyway, the important thing is that there is some kind of argument, philosophical argument to say that there is a gap between these standard neuroscientific approach to the hard problem of consciousness from bottom-up approach. And these are, in our empirical, terms, it can be condensed into the phrase like, why do we perceive phase color motion when our neurons in FFA-B8 MT are stimulated in particular way? And that seems arbitrary. The link between the neural activity to the particular conscious experience seems arbitrary and can be swapped or can be removed or can be sort of added. That's the reason why philosophers argue that there is a huge gap between the empirical research program to the hard program. So now the rescue comes from the IIT. So IIT is not the kind of approach so far, in the sense that it tries to approach hard problem from the top, like this helicopter in this figure. Okay, not IIT doesn't actually deny or or inconsistent with this kind of bottom-up approach to get to the hard problem, but also it tries to give an theoretical guidance from the top to arrive at the hard problem. That's a metaphor. And basically what it tries to do is to try to come up with the explanation on how our conscious phenomenology can be supported by physical mechanism. It's not the other way around. How our physical mechanism produce conscious phenomenology, that's a hard problem. However, how our conscious experience is supported by at least this kind of mechanism that satisfies this condition, then it may be more amenable to explain consciousness or approach to the hard problem. And eventually, this kind of approach may vanish the concept of the hard problem, possibly. So in other words, integrated information theory reverses this arrow. If we experience dog in this way, but not other way, then that kind of experience must have been supported by such and such condition in the physical world. That's the logic of the IIT. So how can we start building a theory of consciousness? The proposal that IIT makes is that first we should start with identifying the key properties of consciousness. And that is what they call as a phenomenological actions. And that includes information or integration, exclusion, existence, and also composition. I'll go into that later. And then propose the properties that physical system must have in order to support these identified properties. So these are the logic of IIT. And in the next video, I'm going to explain how it does it in a little bit more detail.